All right, so in this video, we want to factor these equations by grouping. Let's take a look at the first one over here. So factoring by grouping, you should always try to group by the middle to begin with and split it into two because that's the easiest way to do it. But if I split this in the middle and I common factor each side, well, I can't even common factor anything, and I know that I can't take out matching brackets. So factoring down the middle won't work, which means I have to try and group three terms together and try get a perfect square. If I look at the first three terms, they definitely do not group. But if I look at the last three terms here, these two terms do group, and it's pretty much a perfect square. At least it looks like a perfect square. So I know that I have to group these three terms over here. So the next thing you want to do is, if this sign is a negative, you want to turn it into a positive because we can't perfect square negative quadratic equations. You can only perfect square positive ones. So we want to factor out this negative over here. Now this becomes x squared minus 6x plus 9. And now we can perfect square this. This is a pretty easy perfect square. You should know the method. Square root of x squared is just x. Take the sign from the middle term, and square root of 9 is 3. So I have 1 minus 3 squared. I can factor this by difference of squares. Might be a bit difficult here, so you want to start with going let a equal to x minus 3, and then replace this with 1 minus a squared. And now we can factor this pretty easily with difference of squares. It's just 1 plus a times 1 minus a. We can replace the a's back with an x minus 3. And now we can just expand the internal brackets to simplify. So here I just distribute a positive, so nothing changes in the bracket. And over here, I'm going to distribute a negative, so it's going to change both the signs. This is going to become a plus 3. Then I can combine like terms. So over here, 1 minus 3 is just going to be x minus 2. Over here, 1 plus 3 is 4, so this becomes 4 minus x, and this is my final factored solution. Let's take a look at this second question over here. Again, I want to start by grouping it down the middle, but if I common factor, there's nothing to common factor here. It won't match. So I have to group three terms together. The first three terms don't group, and the last three don't group, which means that my equation is out of order. What I do notice is that this 25 and this 10a can group with this a square. So I can actually just rewrite this equation as a squared plus 10a plus 25 minus b squared. I haven't changed anything. I haven't changed any signs. I haven't moved anything. It's just the order is switched, so nothing really changes. Now I can group these three over here. Basically, if I put a bracket here, that doesn't change the equation at all, and you can tell this is a perfect square. So square root of a squared is a, sign from the middle term, square root of 25 is 5. And now again, you can tell this is difference of squares. We're going to go let x equal to a plus 5. This is going to turn into x squared minus b squared. And then difference of squares is pretty simple, x plus b times x minus b. Then I can replace the x's back with an a plus 5. In this case, I don't need a bracket because there's nothing outside on front of the x's. So I don't need a double bracket. I can automatically just replace it, save a bit of time. And then there's nothing to combine here, so that's my final solution for this second question over here. Let's go to the third and final question. Third and final question is 2m squared plus 10m plus 10n minus 2n squared. And this is a really tricky one. You can try this one before I show it to you. Pause the video over here, try it. It's a really tough one to figure out yourself. So let's take a look. If I group this in the middle, it doesn't look like it's going to work, but you might think that's because this is out of order, right? So let's actually rearrange this a bit to see 2m squared plus 10m minus 2n squared plus 10n. And now it kind of looks similar. So let's try grouping in the middle, see if that works or not. So here I'm going to factor out 2m, left with m plus 5. And here I'm going to factor out negative 2n. And I'm left with n minus 5. These are not the same. Looks like grouping does not work. You could try and organize it in other ways. You could, for example, move the n over here and the m there, but you'd get the same result. You can't really group this because grouping should work one way or another, but if it doesn't, it means this is not the right step. So if I can't group it down the middle, let's see, can I group these three terms together? Nope, because this is not n squared, so you won't be able to factor it with a perfect square. I can't group these three together, so that doesn't work either. Which means that there's going to be another way to group this. And if you notice, this term and this term are both squared terms. So I'm going to move this next to this one. Again, not changing the equation at all. And then I'm going to group in the middle, kind of like this. This might work. So if I group this in the middle, you can see there's some kind of similarities over here. So over here, I can common factor out of 2, left with m squared minus n squared. And over here, I can common factor out of 10, and I'm left with m plus n. Now, again, these two don't match, but what you do notice is that you can actually factor this with difference of squares. If I factor this with difference of squares, it's m plus n times m minus n. And now you notice that you can actually group out an m plus n. So if I group out m plus n or factor out m plus n, I'm going to be left with this 2, this m minus n, these are multiplying, and then plus 10. Now I just want to simplify the inside over here. So m plus n times, I'm going to multiply this into the brackets of 2m minus 2, n plus 10. And then there's no like terms that I can combine over here. But again, what you do notice is you can actually factor a 2 out of all of these. So I'm going to factor out this 2 and bring it all the way to the front. And this turns into m minus n plus 5, and that is my final factored solution.